Welcome this Friday morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu. and I'll respond as soon as I can. All right, so today, eventually, we're going to go on to section 5.6. But first of all, we have several questions people asked about from 5.5. So we are going to, let's see here, take a look at those. So this first question, this is from section, okay, I guess I need to click on the right button here. This is from section, there we go, 5.5 and number 20. It says, consider the following drawing. And then it gives us polynomial values for a of x, b of x, c of x, and d of x. Part A says, what is the difference in the length and width of the one-bedroom apartment shown above? All right, so the length is a of x plus b of x. And a of x is, let's see, a of x is x squared minus x plus 7. And b of x is 3x plus 4. I'm getting these values from up over here, okay? So the length is a of x plus b of x, or this problem right here. So that's equal to x squared minus x plus 7 plus 3x plus 4. Since there's either nothing in front of the parentheses or an addition sign, we just bring out what's inside the parentheses. Combining like terms, we get x squared plus 2x plus 11. So that is the length, okay? Now, let's find the width. The width is c of x plus d of x, which is x squared minus 4x plus 6 plus 2x plus 2. Again, c of x plus d of x, which are up here. Adding these two polynomials together, again, nothing in front. We get rid of the grouping symbol, a plus sign in front. We just distribute the plus sign. Combining like terms, x squared minus 2x plus 8. Okay. It says, what is the difference of the length and width? So we're going to take the length, which is x squared plus 2x plus 11, minus the width, which is x squared minus 2x plus 8. Notice that I grouped both polynomials. It's especially critical that I group the second polynomial because we're going to subtract the whole second polynomial, which means that I need to distribute the subtraction sign. Now, combining like terms, those would cancel. We get 4x plus 3, and that is in units of feet. So the answer down here, part A, should be 4x plus 3. Any questions about that particular example? Okay, then part B says find the perimeter of the apartment. Well, perimeter is 2 times the length plus 2 times the width. So the perimeter would be 2 times the length plus 2 times the width. Okay, so 2 times the length plus 2 times the width. So now we're going to distribute a 2, so we're going to get 2x squared plus 4x plus 22 plus 2x squared minus 4x plus 16, which is 4x squared, x's cancel, and then 38 plus 38. And that, again, would be feet. Okay, let's see here. Okay. All right, any questions about that one? Okay, I'm going to switch the screen to my whiteboard, and then we're going to change this up. Give me just a minute here. And let's see. This is 5.5. 8. 17. Interesting. So the reason I'm saying that is because this student has both of these correct, but we'll go ahead and do them anyway. Maybe they've still got some questions. Okay, so this is, again, in section 5.5, number 8, says subtract the polynomials. So we've got mn plus 9n squared minus the quantity 8 minus 8mn plus n squared. Nothing in front of the first grouping, so we just bring down the contents without the grouping symbol. Distributing subtraction, minus 8, minus times minus, plus 8mn, and then minus n squared. So let's see here. The highest power here is the n's, so I'm going to write the n's first. So let's see, we've got 8n squared. Oh, these are like terms, plus 9mn minus 8. Okay, all right. 8n squared plus 9mn minus 8. Any questions about that one? All right, that takes us to number 17. And we have 2m to the 5th plus m cubed plus 5m squared minus m. And then below that, 3m to the 5th minus 7m cubed plus m squared plus m. And we are to subtract that. So think back to your arithmetic days. If you had something like 3 minus 5, you could rewrite that as 3 plus a negative 5. So basically you changed subtraction into addition of the opposite. We're going to do the same thing here. We're going to change subtraction into addition of the opposite. So that means inside here, I have to have the opposite sign of everything that's there. So this becomes a minus, a plus, a minus, and a minus. But now I've changed it to addition, so I'm going to add them up. 2m to the 5th plus negative 3m to the 5th is negative m to the 5th. M cubed plus 7m cubed is plus 8m cubed. 5m squared plus negative m squared is plus 4m squared. And negative m plus negative m is negative 2m. So there is the answer. Now, you might be wondering, why do it this way? It seems harder this way than the other way. When we get to the last section in this chapter 5.8, we'll look at something called polynomial division. And in that process, we will be using this particular situation. All right, let's see here. That takes care of those. Any questions before I switch to the next one? Okay. So now, give me a minute. Let's see here. Right, there's that. Yeah, 5.5. Another 21. Okay. Let's see here. So this is still in section 5.5. This is number 21 for the student. So we have this fan belt with 3 pulleys. It says the length of a fan belt that wraps around 3 pulleys is, and then it gives that information. Find a polynomial that represents the unknown length of the part of the belt shown in the illustration below. All right, so the total length is 3x squared plus 18x plus 4.5 pi, and that's units of inches. So what we're going to do is we're going to add up all these pieces here, but not including the question mark. So we'll start here and we'll go all the way around that, plus that, plus that, plus that, plus that. We'll get the total of what's given there, and then we'll subtract that from the whole thing to get the missing piece. Okay, so I'm going to start with 2 pi. So 2 pi plus x squared plus 5x, x squared plus 5x, we'll put that in parentheses, plus pi plus x squared minus 3x and plus 1.5 pi. Okay, so I can get rid of those grouping symbols. 2 pi plus x squared plus 5x plus pi plus x squared minus 3x plus 1.5 pi. Well, if we put the x squareds together, we get 2x squared. The x's together, 5x minus 3x is plus 2x. And the pi's together, 2 pi plus pi is 3 pi, plus 1.5 pi is 4.5 pi, and that is inches. So I know the total length, and I know the length of everything but the missing piece. So I'm going to take 3x squared plus 18x plus 4.5 pi minus the quantity 2x squared plus 2x plus 4.5 pi. So now I can drop the first set of parentheses, 3x squared plus 18x plus 4.5 pi, distribute the subtraction, minus 2x squared minus 2x minus 4.5 pi. Combining like terms, 3x squared minus 2x squared is 1x squared, or just x squared. 18x minus 2x is 16x, and 4.5 pi minus 4.5 pi is 0 pi. So my answer is x squared plus 16x inches. And there we go with that one. Any questions about that? Okay. We've got one more set of a couple of problems. So let's see here. .5. Take a look at that. Okay. So now we're going to look at section 5.5, number 5. Simplify the polynomial and write it in descending powers of one variable. Okay, so we've got 1/5 x squared minus 3/8 x plus 2/3 x squared plus 1/4 x. Combining like terms, those two would go together and those two would go together. I'm going to rewrite them, putting them next to each other. Now, to combine those like terms, I need to add their coefficients. To add 1/5 plus 2/3, I need a common denominator of 5 and 3, which is 15. So I'm going to multiply 1/5 by 3/3, which gives me 3/15. I'm going to multiply 2/3 by 5/5, which gives me 10/15. 3/15 plus 10/15 are 13/15 x squared. Okay. Now, I want to combine these two like terms. Negative 3/8 plus 1/4, common denominator there would be 8. So minus so many 8x plus so many 8x. I'm going to multiply, well, this, it ain't broke, so don't fix it, right? I don't need to do anything to the 3/8, but the 1/4 I'll multiply by 2/2, so I get 2/8. Minus 3/8 plus 2/8 would be minus 1/8 x. Now, you could write the answer like it is there, or you could write it 13/15 x squared minus x over 8, because this and this are equivalent. In fact, if you notice in the WebAssign answer, they wrote minus x over 8, but again, you could write it minus 1/8 x. Okay. Any questions there? That takes us to number 18. Yeah, let's see here. So this again is still 5.5, number 18. And part A, perform the operations. So we have 11 minus 2st minus 4s squared t plus the quantity 3 minus 6st. So first of all, we need to get rid of the grouping symbols. Since there's nothing in front of the first one, I can just drop the parentheses. Plus sign here, distributing, gives us plus 3 minus 6st. Let's see, the constants are like terms and the st terms are alike. I'm going to go ahead and write it in descending powers of st. So I'm going to get negative 4s squared t, and then minus 2st minus 6st would be minus 8st, and then 11 plus 3 would be plus 14. So here's the answer to part A. Part B, we have 11 minus 2st minus 4s squared t minus the quantity 3 minus 6st. So again, I can just drop the first set of parentheses because there's nothing in front of it. But here with the second set, I have to distribute the minus sign. Minus 3, minus times minus is plus, or negative times negative is positive. These are like terms, and those are like terms. Again, let's see here. My leading s squared, I'm going to have negative 4s squared t. And then minus 2st plus 6st would be plus 4st. And 11 minus 3 would be plus 8. So there's the answer to part B. Okay, that's all the questions that people emailed to me. Do any of you that are here now have any questions before we go on to the next section? All righty, well, then give me a minute here and I'm gonna set up our screen a little bit differently. Let's see here, get rid of that. So now, all right, can everybody see the whiteboard screen? Somebody? Just, yes? Is anyone even?
Yes.
Yes, thank you, thank you. I wonder, do you guys just, you join in and then you go off and take a nap or something? Because no one ever wants to respond. I just, I'm so lonely here.
No, we're attentive and listening to you.
Oh, good.
We are.
Yeah, what she said.
Good
You're very
answer.
soothing to listen to. That's why.
What's that?
You're very soothing to listen to while you're teaching.
Soothing. I see. So basically, I'm soothing you to sleep. All right.
More like a trance.
More a trance. Oh, what am I? Do I have a target on my head today? Oh, well, I probably deserve it. Okay. So we're going on to section 5.6. And this again revisits some topics from long ago, or maybe not that long ago. First of all, we're going to be looking at just multiplying a couple of polynomial factors together. Let's say, for instance, we have 5m times m. Okay. So 5m times m would be 5m squared. Any questions about that? Okay, good. What if I have the following? Negative 2a cubed times 11a squared. Now, the short answer is just go negative 22a to the fifth. The long answer, in case I'm losing you, is this is like negative 2 times a cubed times 11 times a squared. Recall that multiplication is commutative, so I could commute those two terms if I wanted to. And then I could multiply the constants together and multiply the powers of a together to get negative 22 a to the fifth power. Recall, when you're multiplying two powers with the same base, you add the exponents. Any questions about that situation? All right. I've got, let's see here, 2.5h to the fourth times 2h to the fourth. Well, 2.5 times 2 would be 5. H to the fourth times h to the fourth is h to the eighth power. Again, any questions how I got that? If so, I'll go back and do it the longer way. Okay, how about this one? 3y, 7y squared, negative y to the fourth. So I've got 3 times 7, which is 21, times a negative 1, so negative 21. Y to the 1 plus 2 is 3 plus 4 is 7th power. We all right with that? Okay. How about this one? Negative 2/3 x to the 6th times 9x cubed. So I've got negative 2 times 9 over 3. In other words, what I'm trying to get at is this is in the denominator. So I could come in and I could take this 9 and this 3 and reduce it to a 3 over 1. So now I've got negative 6x to the 9th all over 1, which is just negative 6x to the 9th. Any questions there? Okay, now let's expand this to using the distributive property. If I have 3a times the quantity a plus 2, I'm going to distribute the 3a to each term inside the parentheses. So I get 3a times a plus 3a times 2. So I get 3a squared plus 6a. Now, you can go straight here if you want to. I just did the intermediate step to show what was going on. Any questions there? All right. Negative 6s times s squared minus 3. So this is going to be negative 6s to the third plus 18s. And let's see here. 4/9 a squared times the quantity 9a cubed plus a squared. So I'm going to get 4/9 a squared times 9a cubed plus 4/9 a squared times a squared. So my first product, the 9's reduced down to 1/1, and I have 4a to the 5th. My second product, nothing reduces, 4/9 a to the 4th. Now, notice I did that intermediate step in this problem, and I want to show you the dangers of not doing that. So let's say I take, well, that times that, the 9's reduce out, and I've got 4a to the 5th. But now when I come back here, I might make the mistake of assuming the 9 is gone because I crossed it out, and it's not gone for this next one. That's why whenever there's some things you're going to reduce out, I strongly suggest you take that intermediate step and then reduce each term as possible. Okay. Let's see here. Oh, let's say we're going to do it this way, where we're going to distribute to the left instead of to the right. So this becomes 6x to the 14th minus 72x to the 13th. Okay. Now we're going to multiply a binomial by a binomial, or in general, a polynomial times a polynomial, because here, technically, this is a monomial times a binomial, right? Okay. Well, first of all, let's say I have this. Let's say I have y times the quantity y plus 5, and then another product, 3 times the quantity y plus 5. Okay. So I would go y times y is y squared plus y times 5 is 5y. 3 times y is 3y. 3 times 5 is 15, but oh, this would be a plus 3y, right? Then I'm going to combine like terms and get y squared plus 8y plus 15. Any questions about what I just did there? All right, now let's say we've got y plus 3 times y plus 5. I'm going to do basically the same thing. I'm going to take y times y, which is y squared, y times 5, which is 5y, 3 times y, which is 3y, and 3 times 5, which is 15. Combining like terms, I get y squared plus 8y plus 15. Any questions about that? All right, now I'm going to go back and do this problem yet a third time. The mathematical community calls this situation where we're multiplying a binomial by a binomial FOIL. Let's see, F-O-I-L. And it stands for first outer, inner, and last. The idea being we take the first times the first, then we do the outer two, then we do the inner two, and finally the last two. And then of course, combining like terms at the end. So they call it FOIL. We basically have four products. The first one here times the first one there, back to the first one times the last one there, which are, well, or the outer ones, then the inner ones, and the last in each binomial factor. Okay. All right. Let's see here. Suppose we have a plus 4 times a plus 5. So we get a times a is a squared. A times 5 is plus 5a. 4 times a is 4a. And 4 times 5 is 20. Combining like terms, a squared plus 9a plus 20, and there you get a trinomial, which is the product of the two binomials. All right. Any questions? Now let's take a look at some more examples then. 3x minus 4 times x plus 5. 3x times x, 3x squared. 3x times 5, 15x. Minus 4 times x, minus 4x. Minus 4 times 5, minus 20. Combine like terms, 3x squared plus 11x minus 20. As I've mentioned in the past, if I'm going too fast, you need me to slow down, stand on one leg and gargle peanut butter, whatever, let me know. I'll do what I can to help you. Otherwise, I'll just keep plodding along here. Okay. How about this one? 2.6x minus 3 times 2x minus 1. I just want to point out, sometimes my 2's have loops and sometimes they don't. But if it's a Z, there's always a slash through it, okay? So if you're confused about that, that is a 2. Okay. 2.6x times 2. Well, 2 times 2.6 would be what? 5.2. And then x times x, x squared. 2.6x times minus 1 would be minus 2.6x. Minus 3 times 2x is minus 6x. And minus 1 times minus 3, minus 3 times minus 1 is plus 3. Combining like terms, 5.2x squared minus 8.6x plus 3. Okay, how about with some fractions? 8t minus a half times 4t minus 5 halves. So 8t times 4t is 32t squared. 8t times minus 5 halves. I'm going to write that. So that's going to be what? Minus, and then 8t times 5 halves. I'm going to come back to that in a minute. And then minus 1/2 times 4t, and then minus a half times negative 5 halves. So I'm going to do that intermediate step here as well. So 32t squared. The 8 and the 2 reduced to 4/1. So minus 20t over 1, which is still just minus 20t. Okay. Minus a half times 4t, 4/2 is 2/1. So I get minus 2t. And then the last product, negative times negative is positive 5/4. Remember, when you're multiplying two fractions, you multiply straight across. Now, combining like terms. So we've got 32t squared minus 20t minus 2 more t would be minus 22t plus 5/4. All righty. Now, let's expand our horizons. Instead of multiplying a binomial times a binomial, we're going to multiply a binomial times a trinomial. Well, instead of having 4 products like with FOIL, we're now going to have 6 products. So rather than calling it FOIL, I'm going to just do this. I'm going to start with the first term in the first factor, and I'm going to multiply it by each term in the second factor. So x times x squared is x cubed. X times minus 2x is minus 2x squared. X times 3 is plus 3x. Now, having multiplied this by everything in the parentheses, I'll move on to the next term. 2 times x squared is plus 2x squared. 2 times minus 2x is minus 4x. And 2 times 3 is plus 6. So there's my 6 products. Combining like terms, x cubed, the x squareds will cancel. 3x minus 4x is minus 1x plus 6. So there's the answer of the binomial times the trinomial. All right. Let's do a similar one, only now the trinomial comes first. X squared plus 6x plus 7 times 2x minus 5. So I'm going to take x squared times 2x, which is 2x cubed, x squared times minus 5, which is minus 5x squared. 6x times 2x is 12x squared. 6x times minus 5 is minus 30x. 7 times 2x is 14x. 7 times minus 5 is minus 35. Combining like terms, 2x cubed minus 5x squared plus 12x squared is plus 7x squared. Minus 30x plus 14x is minus 16x, and then minus 35. Now, for whatever reason, some students look at this and they don't like it that way. They want the smaller polynomial in front. So they use the commutative property of multiplication and then set it up that way. You're going to get the same final answer either way. Okay, because again, multiplication is commutative. I can take those two factors and reverse their order, still get the same results. Well, we're going to go out into the deep end of the swimming pool here. We're going to take a trinomial times a trinomial. So in fact, we're going to have 9 products. So here we go. W squared times W squared is W to the 4th power. W squared times minus W is minus W cubed. W squared times 3 is 3W squared. So let's move to the next set. W times W squared is W cubed. W times minus W is minus W squared. W times 3 is 3W. Let's move to the next set. Minus 9 times W squared is minus 9W squared. Minus 9 times minus W is plus 9W. And minus 9 times plus 3 is minus 27. So there's my 9 products. Combining like terms, W to the 4th minus w cubed plus w cubed, those would cancel out. 3w squared minus w squared is 2w squared. Minus 9w squared would be minus 7w squared. 3w plus 9w is 12w, and then minus 27. So there's the answer with all of that. There's a lot going on there. You just need to keep track of things. I strongly suggest drawing the lines like I'm doing there so that you don't do the same thing twice and keep track of everything. All righty. Now we're going to take a look at polynomial multiplication using what is called vertical form. So let's say I've got x squared minus 2x plus 1 times x plus 2. Now, I suppose I could put a multiplication dot or symbol out there using the old arithmetic x. That might be confusing because the x's are variables. So we're just going to say we're going to multiply it, okay? So 2 times 1 is 2. 2 times negative 2x is negative 4x, but I need a plus sign there. 2 times x squared is 2x squared. And then x times 1 would be x, that would go here. X times negative 2x would be negative 2x squared, but this was a plus, right? And then x times x squared is x cubed. And then we add them up, 2, negative 3x, that's going to be a plus. That's a 0, and then x cubed. Now, we could write that, though at this stage of the game, we don't need to. So I'm just going to write it like that, okay? Later on, there'll be a context where we might actually include that. We'll talk about that when we get there, but so we've got that situation. Okay. Let's see here. Take a look at these problems. These are called lookalikes. So we've got, let's see here. Part A is a plus 3 plus a squared minus 3a plus 9. Part B says a plus 3 times a squared minus 3a plus 9. I have to tell you, a common mistake that I see students make on their tests is they get a situation like part A, but they ignore that plus sign separating the two polynomials, and they do it as if though it was like part B. So be very, very careful, okay? Part A, we're just adding two polynomials. Nothing in front of the first group, a plus sign in front of the second group, so we get rid of the parentheses. Combining like terms, a squared minus 2a plus 12. A squared minus 2a plus 12. So that's adding those two polynomials. Part B, multiplying those two polynomials, we're going to get a cubed minus 3a squared plus 9a plus 3a squared minus 9a plus 27, which is a cubed. A squareds cross out, the 9a's cross out, and plus 27. So again, we get very different answers. So how about pay close attention to the operation? Just washed my tongue and I can't do a thing with it apparently. All right, so tonight we're going to look at multiplying polynomials together. I will be back again at 1:15 to 2:15 today. If I don't see you then, I'll see you on Monday at 10:30. Have a great weekend and go Mariners. All righty. We'll stop the recording. Oops. We'll try and stop the recording. Here we go.